For this question, I have drawn the exactly same diagram at the bottom, that is this diagram. So the diagram shows the track ABCD which lies in a vertical plane. So the track A, B, C and D in the vertical plane. The section AB is a straight line inclined at an angle of 30 degrees to the horizontal and is smooth. So the section AB is a straight line and is inclined at an angle of 30 degrees to the horizontal. Then the section BC is a horizontal straight line and is rough. So we have given that the section AB is smooth and BC is rough. So the section BC is rough. That means there is an effect of friction, that is mu r. The section CD is a straight line inclined at an angle of 30 degrees to the horizontal and is rough. So the section CD is inclined at an angle of 30 degrees to the horizontal. So this angle is also 30, this angle is also 30, and there is an effect of friction, that is mu r. The length of AB, BC and CD are each 2 meters. So the length of AB, BC and CD are same, that is 2 meters. And AB is a smooth plane, that is smooth. BC and CD are rough planes. A particle is released from rest at A. So since the particle is released from rest, that means initially it has a speed of 0 from A. The coefficient of friction between the particle and both B and C, BC and CD is mu. That means the coefficient of friction is mu. There is no change in the speed of the particle when it passes through either of the point B or C. So either of the point B or C, it has no change in speed. That means when it passes through B, suppose it has a speed of V, so its speed remains V, and when it passes from this point to this point at C, the speed, suppose it is 2, so it remains 2. That means there is no such change in speed between this plane and this plane for B and this plane for C. That means there is no change in speed of the particle when it passes through either of the point B or C. It is given that mu is 0.1. So we have given the value of mu. Find the distance which the particle has moved up the section CD when it has a speed of 1 meter per second. So we need to find the distance when the particle has moved up the section CD. So up the section CD when it has a speed of 1 meter per second. So when it moves up the section CD, suppose at a distance it has a speed of 1 meter per second. Suppose at this distance it has a speed of 1 meter per second. Now we need to find this distance. So to find this value of distance, first of all, for the section AB, if we just consider, then we don't have given the mass of the object, so we consider the mass as m. So the mass as m. So for the object, the weight is acting vertically downward, that is the mg is acting vertically downward. And this is the, if we break the weight into its component, then it would be mg cos theta. So mg cos 30. So this side is cos and this side is sine. So the opposite is sine and the adjacent is cos. So the force that is parallel to the plane, that is mg sine theta, that is parallel to the plane, is equal to mass into acceleration. And since the section AB is smooth, that means there is no effect of friction. So mg sine 30 is equal to mass into acceleration. So mm. So since m is same, so we can cancel this, and acceleration comes to be 5 meter per second square. So the acceleration is 5 meter per second square. And what is the velocity of the particle at point B? So the velocity, we consider this as v. So v square minus u square is equal to 2as. So vb square minus, since at A it is at rest, so the speed is 0. That means the value of u is 0 is equal to 2 and the acceleration is 5 and the distance AB, BC and CD is 2 meter. So we have given the value of distance as 2 meter. So the speed at B, that is VB, is equal to root over 20 meter per second. So the speed at B is root over 20 meter per second. So we know the speed at this point. So we know the speed at B. Now to find the speed at C, so to find the speed at C, that is VC, so VC square minus VB square is equal to 2AS. So what is the value of acceleration? Now at this plane BC, we know that there is an effect of friction, that is mu r. Since the friction is acting, so the acceleration value must change. So if we consider the object is at this point, so for this point, so there is no forward forces acting. Now the weight is acting vertically downward and there is no forward force acting. But we know that there is frictional force, that is mu r. So the forward force is 0. So forward force is 0 and minus mu r. So mu r, and we have given the value of mu as 0.1. So 0.1 r. And what is r? R is equal to, so weight, that is mg, is acting downward. So r is equal to this force. That is the normal reaction force. That means r is equal to mg. So r is equal to mg. So mg is equal to mass into acceleration. So mass into acceleration. So here m and m cancels, and g, we know that the g is 10 meter per second square. So after substituting the values, we get the acceleration as minus 1 meter per second square. So we know the acceleration. So 2a, and the distance is from b to c, the distance is 2 meter. So 2a is plus u square. There is the speed at b. So we know the speed at b. So after substituting these values, we find the speed at c, that is vc square is equal to 16. Vc is equal to plus minus 16. That is Vc is equal to 4 or minus 4. So minus 4 is not the answer, or it is inadmissible. And our answer is 4 meter per second. So for point C, the speed is 4 meter per second. So for point C, the speed is 4 meter per second. That is Vc is equal to 4 meter per second. So we know the speed at this point, and find the distance when the particle has moved up the section CD, when it has speed 1 meter per second. That means when it moves up the section CD, it has a speed of 1 meter per second. That means at the topmost point, it has a speed of 1 meter per second. And at point C, that means at the bottom point, it has a speed of 4 meter per second. And we need to find the distance, that is the distance. So we can use the formula v square minus u square is equal to 2as. Now to find the value of speed from this equation, we need to first find the acceleration. So what is the value of acceleration? So to find the value of acceleration, so let's consider the object is at this point. So the weight is acting vertically downward, that is mg, and this side would be mg cos theta and mg sin theta, where the value of theta is 30 degree, and the frictional force is mu r. So mu r, so is that this is backward force, and the object is moving upward. Since the object is moving upward, so the frictional force is acting backward. So negative frictional force and the downward component of weight, since the force that is parallel to the plane, there is a frictional force and the weight is acting downward while the object is moving upward. And since the downward component of weight is downward, so that means it is negative. So negative mg sin 30. So mg sin 30 is equal to mass into acceleration, where we can cancel the value of mass. After cancelling the mass and substituting the value of mu that is given, that is 0.1, r is the normal reaction force. So since r is the normal reaction force, so this component of weight is acting downward, so the r is acting vertically upward. So what is this component of weight? So this component of weight that is perpendicular to the plane is mg cos theta, where we know the value of theta is 30 degree. So r is equal to this value, so we substitute the value of r and find the acceleration as negative 5.866 meter per second square. So we know the value of acceleration. Now using the equation v square minus u square is equal to 2as. So we know the final speed as 1 meter per second, initial speed as 4 meter per second is equal to 2as. So after substituting the values, we find the distance as 1.28 meter. So we have solved the part A, that is, this is the part A. Now for part B. So for part B, we have drawn the exact same diagram that is given in the question, that is this diagram. Then after drawing the diagram, it is given instead that with a different value of mu, the particle travels 1 meter up the track from C before it comes instantaneously to rest. So for a different value of mu, so the value of mu is not the same that is given here, that is, it is not now 0.1. So the value of mu has changed. So the value of mu has changed, and for this changing value of mu, the particle travels 1 meter up the track from C. So from point C, the particle travels 1 meter up the track. So since it travels 1 meter up the track, so this distance is 1 meter. So we consider the distance as cx. So distance cx as 1 meter. So it travels 1 meter up the track before it comes instantaneously to rest. That means after traveling this 1 meter, it comes to rest. That is, the velocity at this point is 0. Find the value of mu. So we need to find this different value of mu and the speed of the particle at the instant when it passes c for the second time. So what does this mean? So we need to find the value of mu and the speed of the particle at the instant when the particle passes c for the second time. That means after the passing through this point, it comes instantaneously to rest, and after coming instantaneously to rest, it again moves downward to c to this point, and we need to find the speed of the particle when it is again at point c. So we need to find the speed of the particle when it is again at c. So first of all, again if we consider the section AB, so mg sin theta, that is the downward component of weight that is parallel to the plane. So the component of weight parallel to the plane is equal to mass into acceleration, and since the section AB is smooth, so AB is smooth, BC is rough, and CD is rough. That is given. So that is already given here that AB is smooth, BC is rough, and CD is also rough. Now, since AB is smooth, that means the only force is acting the downward component of weight that is parallel to the plane. So mg sin 30 is equal to mass into acceleration. So acceleration is 5 meter per second square. Now using acceleration, what is the speed at this point? So v square minus u square is equal to 2s. So initially at this point it is at rest, so u is equal to 0 and 2s. So vb, that means the speed at this point is root over 20. So we know this value till now. Now we know the speed of b at this point. Now suppose the object is at this point. So for this point, the weight is acting vertically downward, mg, and the normal component of the vertical component, that is the normal force, is r. So normal reaction force is r. Now this force is acting vertically upward, and the mu r, since the object is moving in this direction, after passing through this point it is moving in this direction, so the mu r is acting in this direction, that is towards the left. So there is no forward force, so there is no driving force, minus the backward force, that is mu r. So mu r is the backward force. Now why the object has no forward force? Because the object started at this point, and after passing this point, suppose the object is at this point, so if we consider this point, then we can see that there are no other driving forces that are acting on the object. The object has passes through this point, but now at this point there are no driving force acting. The only force is acting is the resistive force, and no driving force is acting. Therefore, for this point there is no driving force is acting. So no driving force minus mu r is equal to mass into acceleration. So minus mu, and the value of r is, since it is mg, so r is equal to mg. So minus mu r is equal to mass into acceleration. So mass into acceleration, so we cancel the mass, and acceleration is equal to negative mg, negative mu g. So acceleration is equal to negative mu g. So this is for the acceleration. Now what is the speed of the particle at c? So the speed of the particle at c, that is vc. So we know the speed of the particle at b, that is vb, and we know the acceleration that we have found. Now what is the speed of the particle at c in terms of mu, since we don't know the value of mu? So v square minus u square is equal to 2s, where v is the speed of the particle at c, square minus u square is equal to 2, acceleration is negative 10 mu, and s. So the distance AB, BC and CD, we have given that it is 2 meter. So substituting the value of 2, we find Vc square is equal to this value. That means the speed of the particle at C is this value. So we know the speed of the particle at point C, speed of the particle at C in terms of mu. Since we need to find the value of mu, so considering the mu, we find the speed of the particle at C. So we know the speed at C, and we know that this distance is 1 meter. So this track is 1 meter, and the speed at this point, since it comes to instantaneous rest, so the speed at point is 0. So again, by using v square minus u square, so first of all, okay, so we find the vc square, that means the speed of the particle at c. So we have found the speed of the particle at c. Now what is the acceleration in this plane? So first of all, for the acceleration in this plane, that is in this plane, so the weight is acting vertically downward, that is mg, and this side would be mg cos 30, that is the angle is 30, and this side would be mg sin 30. So for this object, the mg sin 30 is acting backward, and since the object is moving upward, so mu r is acting backward, that is mu r, and here this component of force is r, so r is equal to mg cos 30. So mu r minus mg, and there are no forward force, so minus mu r minus mg is equal to mass into acceleration, where there is no forward force, so minus mu, and the value of r is mg cos 30. So r is mg cos 30, there is the vertical component of weight, so mg cos 30 minus mg sin 30. So minus mg sin 30, that is the downward force. So negative mu r minus mg sin 30 is equal to mass into acceleration. So we find the acceleration in terms of mu. Now we find the speed c square in terms of mu and the acceleration in terms of mu. So speed c square and acceleration in terms of mu. Now we have found these values. Know the speed c square in terms of mu and the acceleration in terms of mu. So the acceleration in terms of mu, that is negative 8.66 minus 5, and the u square in terms of mu, that is 20 minus 40 mu. So speed c square in terms of mu. Now for the distance cx, so distance cx, we have given the distance the particle travels until it comes to rest is 1 meter, so 1 meter, and the speed at this point when it comes to instantaneous rest is 0, and u square, we have given the value of u square, that is the initial speed square, so v square minus u square is equal to 2s, so final speed square is 0 minus u square, so we have given the value of u square, that is 20 minus 40 mu is equal to 2, and the acceleration, so we have substituted the value of acceleration in this equation, and the distance is 1 meter until it comes to rest. So after substituting these values, we can easily find the value of mu, that is 0.17445, that is approximately 0.175, that is the value of mu, and it has no unit. Now we find the value of mu, that is the second value of the defined value of mu. Now again at point C, so again at point C, we need to find the speed. That means the speed of the particle at the instant when it passes C for the second time. That means when it passes C for the second time, what is the speed of the particle? So to find the speed of the particle, so first of all, for the object, for this object, now the particle after moving from X downward, so the particle comes to rest at point X, then again the particle is moving downward, and we need to find the speed at C again when it moves downward. Since for now the object after coming to rest at X is moving downward, so it moves upward, then again it moved downward, so now the particle after moving upward, it is moving downward. Since the particle is moving downward, so mu r is acting upward. Since the particle is moving downward, so mu r is acting upward. So mu r is acting upward. So the object is moving downward. So the downward component of weight is, that is parallel to the plane, is mg sin 30, and now this force is acting in the direction of the movement. This force is acting in the direction of the movement, that is this direction of the movement. Therefore, this force is positive, and mu r is the resistive force. Therefore, it is negative. So minus mu r is equal to mass into acceleration. And after substituting our values, that is the g sin 30 minus mu r is equal to mass into acceleration. And if you cancel the value of masses, so the acceleration comes to be this value, that is 3.489 meter per second square. So we know the value of acceleration. So we know the value of acceleration. Now the acceleration is for the object when it is moving downward. So the acceleration is for the object when it is moving downward. So we know the value of acceleration. Now the speed again at C. So that is vc square is minus u square is equal to 2s. And what is the u? U is the speed at this point when it is instantaneously at rest. So u is 0. So 0. That is u is 0. So vc square is equal to 2as. So the distance cx, we know that this distance is 1 meter. So after substituting our values, and we get the value of vc as this value, that is plus minus 2.641, that is vc is equal to 2.64 meter per second, or negative 2.64 meter per second, negative 0.64 meter per second. Sorry, this is negative 2.64 meter per second, negative 2.64 meter per second. So Negative 2.64 inadmissible or not the answer, and our final answer is 2.64 meter per second. So our answer is 2.64 meter per second. That is our final answer. That is the speed of the particle when it is again at c.